Sum of cubes or perfect cubes. Perfect. Once you say that, remember, you will have to give us a binomial times a. Excellent. Very good.
B plus 1,
Yes.
B squared minus B plus 1.
Excellent. I forgot to ask you from the beginning, how many solutions do we have to write? Yes. So degree 3 solutions. Perfect. Can anyone give us the first solution here? B equals perfect. What will be the second and the third? Where will they come from, the second and the third? From b squared minus b plus 1 equals? Exactly. And here I'm going to write a note. Wait until chapter 11. We don't know how to solve this equation now. Today we are not equipped. Maybe by the end of the class today we will be able to solve this and we'll come back to it. But we don't have information on how to solve that. Very good. 2 more. And then we start chapter 11. So x to the third minus x squared plus 4x minus 4 equals 0. It's a what? I'm looking in the book because I would like to kindly ask you to check your understanding of factoring with problems, page 411, from 1 through 100. Choose every other odd and check the answer in the back. So this is a total of 25. So you start with 1, skip 3, do 5, skip 7, do 9, skip 11. After you do these 25 and you check the answer in the back, you should be quite happy with your factoring skills. If you're not, go back and do the other ones that are odd and check the answer in the back that you skipped. Please. That's how you know whether you can perform on your own. And make a list of questions and come back with them on Thursday. Okay, so it's a polynomial. It's in descending order. No greatest common factor to all of them. No negative leading coefficient. What do I do? That's it. There is nothing else here. Very good. So from the first two, I factor out. Good. What is left in parentheses? What should I have from the other two? And now I look. I need sign and factor. Without the sign or without the factor, I can continue. So I have to have a sign and I have to have a factor. So if you pull out -4, you'll say -4. If you pull out 4, you'll say +4. Exactly. So then the next factor that comes out will be x minus 1. And I forgot again to ask you from the beginning, what is the degree of the polynomial and how many solutions will you find? 3 solutions. Good. So what is left in parentheses? From here I have x squared, and from here I have +4. For now I have 2 factors, and I'm going to write x equals what for the first factor? Good. And let's write the second equation. What will you write? Dictate what I should write for this second equation. I have to write x squared. I have to write the second equation. How do I write the second equation? X squared equals. I know how to solve this from chapter 10. How do I do it? Exactly. And then what happens now? Very good. I can factor, but I have another method that allows me to solve this. What should I do? This is how we started. This was the first problem we did. We had x squared equals 100. We applied square root to both sides, and we got plus or minus 10. We cannot forget this method. This comes back again to us, with us, or torturing us if you want, in chapter 11. It's a very important method. So taking square roots. So I take the square root from the left and the square root from the right. How many solutions do I have to come up with? Exactly. Be careful now. So x equals. How do I get those two solutions? Yes. So the square root of -1 times the square root of 4, which this is, and this is excellent. But that doesn't solve one question. I need two solutions. Exactly. Always ask yourselves, am I on the right track? Am I looking for two solutions? Or how many solutions am I looking for? And so on and so forth. So yes, here are three solutions. X equals 1, x equals 2i, x equals -2i. Last one, 3x cubed plus 2x squared minus 27x minus 18 equals 0. So in descending order, greatest common factor, none. Negative leading coefficient, no. What do I do now? That's it. From the first two? Very good. In parentheses?
3x.
Careful. Did I copy it incorrectly? That's very possible. Let me look. It's plus.
3x plus 2.
Good. Notice one thing, that if you forget the equal symbol and 0, you're going to stop and you're not going to solve. So be very careful on that. So then what do I write next? What should come out of the other two? Good. Now I look. I need sign and factor. Say it again. -27 times 3 will not be -27. So whatever I put here times 3x has to give me this. See, like in the previous problem, 4 times x is 4x, 4 times -1 is -4. If I put here 27, 27 times 3 is not going to be that. And 27 times 2 is not going to be that. Negative? Good. -9 times 3x and -9 times +2. Perfect. So then what comes out? Good. And what is left in parentheses? Again, I forgot. How many solutions are we looking for? They can be real or imaginary. I don't care. So here you saw we had one real solution and two imaginary solutions. Good. So what do we have in parentheses? What do we do with x squared minus 9? Perfect. See how many times just in one lecture this appeared? It's very useful. That's why I put it on our agreement on the first day of classes. Not because I wanted to torture you, but because I knew we would be there all the time. So I have 3x plus 2. And then,
X plus 3, X minus 2.
so finally you will give me 3 solutions. And we can start chapter 11. And the solutions are
Negative 3, positive 3, and negative 2.
excellent. The whole chapter 11 is about quadratic functions. So if you remember, I gave you a handout with functions. I'm going to come back to it on Thursday again. So quadratic equations and functions. And you can say, well, what have we been doing so far? We've been talking about quadratic equations like forever. Why now again? So quadratic equations and functions. We will talk more about quadratic equations right this minute. The general form of a quadratic equation is ax squared plus bx plus c equals 0. This is the general form where a is not 0. So a, b, and c are real numbers. But a cannot be 0. Why? Why a cannot be 0? What happens if a is 0? This term,
That whole thing is 0.
right, is this quadratic anymore? No. It becomes what type of equation? How do we call this? Exactly. It's no longer quadratic, it will be linear. Excellent. Very good. So, we know 4 methods of solving quadratic equations. 1, 2, 3, and 4. And I know what's on your mind. No, I don't. But I can say that possibly you're thinking, really? Do I really need 4 methods? What's wrong with 1? Here is the reason why we look at 4 methods. I wish all polynomials were factorable, but they are not. So the first method is factoring. But since not all polynomials are factorable, and we encounter 2 factorable polynomials that took us some time to figure out those 2 numbers. So not all polynomials, number 1, are factorable, and some of them are difficult to factor. So that's why we came up with other methods. Okay. Number 1, not all are factorable, and some of them are difficult. I will consider this one done for now, because we've spent 3 hours on it. Okay. Oh, and also the entire semester. The second method is very useful. We know it. Taking square roots. Very useful. So if you remember the first example we looked at, look, I didn't have to move it to the other side. I didn't have to factor. I didn't have to use the zero product principle. Look how quickly we determined this. Very useful method, but it's again not applicable in all cases. Because if I have something like this, if I add here an x, I can take square roots from it. So it has to be in a specific form. So I will consider it done, but I will show more examples right now. The third method is honestly a method that I will never apply in solving a quadratic equation unless I'm taking a test and my professor says you must solve it using this method. Otherwise, I will never, ever apply this method. Ever. What's the use of it? Well, honestly, it works partially, not entirely. You'll see in a moment what I'm saying. For solving quadratic equations. But it's, as I said, partially. Because alone, this method that I'm going to write here does not solve the quadratic equation. But it's an important method for something else that follows in algebra. Not in this course. In the next course. That's why we presented it from here. And we say, yeah, we can use it in solving quadratic equations. Not alone, though. You'll see in a moment. It's called completing the square. We're going to talk about this in a minute, but I want to practice a little bit more of number 2, and then we'll continue with number 3. So one more time. The first one works only if polynomial is factorable, and if it does not take me 10 minutes to factor. So, because students always ask me, okay, you're listing here 4 methods. When do I use what? So here's my answer. I will factor if it takes this to factor. If it takes me 10 minutes, no. Unless I'm forced to use a particular method. Otherwise, I will not use it. When do I use this? Well, in specific cases in which I have something with x squared and a number alone on the other side. Whatever the number is, positive, negative, I don't care. But x somewhere in here squared and a number on the other side. I will use this. Otherwise, I will not. When do I use this? Never. Unless I'm forced to. But I need to know the method. When do I use this one? Almost any time you want. And that's quadratic formula. Now, if the middle term is missing, I will not use this. It's too much work. If the middle term is missing, this is so much easier. Move c to the other side, divide by a, and take square roots. So I will use this when I have a, b, and c. If one of them is missing, I will not use this because there are easier methods than this. Okay, so this is done. I want to practice this, and then I'll come back to that. One more time. When? This, if it doesn't take long. This, in specific situation, when I can take the square root. This, never, unless I'm forced to. This, anytime when I have a, b, and c. Even if it's factorable and I'm lazy and I don't want to factor. This will always work. This will not always work. This will always work. This will always work. This will always work. All these 3 can always be applied. This one, if I complete the square, then I can take square roots. So even in other cases. But this one is not always applicable. Because if the polynomial is not factorable, it's not factorable. I can't use it. Okay. So I would like to choose some problems. This is my page 10. Some problems from page 659. So this is 11.1, completing the square. But I'm not starting with that. I'm starting with practicing a little bit of taking square roots. So what if I have problem 8? Like 2x squared minus 4 equals 0. How will I solve this equation? Exactly. So I have 2x squared equals 4. Factor simplify. When I can factor, I simplify, or both at the same time. Right? Don't forget how many solutions I have to get. Okay,
and plus or minus 3.
that's it. Okay, let's look at 12. Same page. Y plus 4, everything squared, equals 27. If you see this problem, would you move 27, square this? Of course not, because this is already set up for you to take square roots right away. And this is a very useful method. So then I have y plus 4 equals, I cannot forget plus or minus, and I have to split the square root of 27 into 9 and 3. So the square root of 9 will be the square root of 3. All I have to do is move 4. So y equals -4 plus or minus 3, the square root of 3. We've done these examples in chapter 10. I just would like to look at one more. Let's say 26. So y minus 4 squared plus 18 equals 0. And then I'll explain the method of completing the square. Yes, excellent. So then I have y minus 4 squared equals -18.
And you have to split that square root of -1,
Yes,
square root of 9, square root of 2.
excellent. So y minus 4, I cannot forget something very important.
That's plus or minus.
Very good. So this is 3. This is I. Exactly. And all I have to do is move 4. And it's done. See how elegant this method is? If all is set up for it. Good. So now we're ready for completing the square. So I can come back here and say done, done. So we are talking about complete the square, the third method, and then the quadratic formula. Okay, here is the background. So the title basically is Solving Quadratic Equations by Completing the Square. But first I'd like to talk about completing the square. If I say to you x squared, I give you x squared plus 4x. What should I have here such that I get a perfect square? And which perfect square am I talking about? Not just what should that number be, but what should I get as the final answer? And this comes back to the same contract we made 2 months ago. Exactly. Where should it be 2? What should this be?
X plus 2.
Exactly. So then what should this be?
4.
Exactly. So how did we get this? Here's how we did it. Because we know the formula, how to go back. First term squared plus 2 times the first times the second, plus the second term squared. All we did basically was take this coefficient and divide it by 2. And that's how we got this. This is basically the method of completing the square. So let's go slowly through one problem, 36, and then we'll do more. 36 on page 660. So I have y squared plus 6y equals -8. You could say this is factorable. I'm going to move 8 to the other side so it equals to 0, blah, 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 and factor. True. But the problem is asking us not to use any other method but complete the square. So here's how we proceed. In step 1, we identify the middle coefficient, which means the polynomial has to be in descending order in order to correctly identify the middle coefficient. Can anyone give us the middle coefficient? Exactly. In step 2, I divide 6 by 2, like I did here with 4. Divide 6 by 2. What do I get? In step 3, square 3. The number that I got from step 2. When I square 3, what do I get? Good. Final step, step 4. Add 9 to both sides. Now, before I do that, I'm going to ask you, am I allowed to add 9 to both sides of an equation? Yes. Will that change the solution? No. It's like subtracting 5 from both sides, or multiplying both sides by 3, or dividing both sides by 2. That is a basic principle of equations. Which one was not a basic principle of equations and we had to go back and check? What did we do when we said, uh-oh, this is not legitimate, entirely legitimate, so I have to go back and check? When was that? When we... Exactly. I had no choice. Squaring both sides, it's not legitimate, entirely legitimate. It could come up with solutions that were not good in the original problem, extraneous solutions. But here, adding 9 to both sides is not going to affect the solutions. Good. So I'm adding 9 here, and I'm adding 9 here. It must be on both sides. Otherwise, I change the problem. But if I add 9 to both sides, I don't change the problem. So then I have y squared plus 6y plus 9 equals how much is on the left on the other side? Perfect. Now I have a contract on the left-hand side. How do I handle the left-hand side? I know exactly how to handle it because I found that 9 specifically so that the left-hand side is a perfect square. That's how we worked on the problem. To make the left-hand side be changeable into a binomial squared. Which binomial? Indeed. What I squared to get 9. Let's check one more time. First term squared plus 2 times the first times the second plus the second term squared. Now, okay, we complete the square. Did we solve the problem? No. So coming back to our list of methods, I complete the square. And so what? If I don't go back and take square roots and employ the method 2, I will never solve. So as you see, this is not a method that is really helping here. Because if I complete the square, I didn't solve. I have to go back and take square roots. We learn this method now for something else in algebra that follows. So we take the square root. How many solutions I have to write? So then what do I write on the right-hand side? When I take square roots?
On the right-hand side now, it'd be 1.
Right, but not yet. Not only. I took square roots.
Oh, plus or minus.
Exactly. That's what I was waiting for. That's why I said how many solutions. So if you connect in your head solutions to plus or minus, you will never forget it. 2 solutions, if I don't put plus or minus, I will only find 1. So then I have to move 3. So I have y equals -3 plus or minus 1, and I have to separate them. There are 2 options, y equals and y equals. Y equals -2 and -4. Excellent. Indeed. That's the method of completing a square. Of course, it can get more difficult than just this. When can it, or how can it get more difficult? If this number is not divisible by 2, then I'll have to work with fractions. If this number in front is not 1, first I have to divide by it. So yes, it can get difficult. Okay, on page 660. X squared plus 8x plus 1 equals 0. And that is problem 51. We're asked to use completing the square. First step. Which is? Then I divide 8 by 2. And I get? Then I square 4 and I get? Good. Careful how I add it. I will put it right here next to 8x, and then of course on the other side. So x squared plus 8x plus 16 plus 1 equals 16. Do not make the mistake of combining 16 with 1. You can, from the very beginning, you can move 1 to the other side already in order not to make a mistake. So x squared plus 8x plus 16 subtract 1 is 15. So your first step could be, if it's better or easier for you, could be moving 1 to the other side first. Now I know what the left-hand side is. I know it from factoring. I know it from our contract. I know it from all over the place. And I also know it because that's how I determined that 16. That's it. Now you finally understand why I tortured you with that. Now what? How many solutions? Taking the square root. So I have x plus 4 equals? Thank you. There is nothing you can do here. All you have to do is just move 4. This is it. There is no need to separate these two. Why? You can simplify them. So there is no need. Now let's look at a situation that is more complicated. Let's say y squared plus 3y minus 4. Y squared plus 3y minus 4. Again, we are forced to use completing the square. Okay, middle coefficient divided by 2. And no, do not use 1.5, just say 3 over 2. Square 3 over 2. Very good. This is what we are adding. Let's move negative 4 to the other side, or 4 to the other side first. Y squared plus 3y plus 9 over 4 equals 4 plus 9 over 4. Be very careful. If you don't put it on both sides, you're changing the problem. Now the left-hand side, we know what it is. We made it happen, so I know exactly what it is. What is it? Three halves. What I squared to get 9/4. What about the right-hand side? I need to multiply the top of the first fraction by? What is the least common denominator? There is only one denominator, 4. So then what do I multiply the top of 4 over 1 by? Good. How much is 4 times 4? 16 plus 9. Good. So here I am sweating to get the square completed, and now I can find the answers. I have to remember to apply another method. So completing the square alone does not do the job. That's what I said, it's a partial solution. So what do I do next? The reverse. The reverse of square. No, the reverse of square is taking square roots. I know what you meant. So then On the left-hand side, I have y plus 3/2. How many solutions I expect? So then I will not forget. Perfect. And what do I have? I know this from chapter 10. What is it? Split it in two. Split in the top and the bottom separately. Good. I move 3/2 to the other side. Y equals negative 3/2 plus or minus 5/2. And I have to separate it. I have no choice. How do I separate this? And tell me what we get. So it's negative 3 over 2. Yes, negative 3 over 2 plus 5 over 2 is 2 over 2. Very good. Y equals 1. And negative 4 indeed. So negative 3 over 2 minus 5 over 2 is negative 8 over 2, which is negative 4. Perfect. Now let me show you one more example, and then we'll look at the quadratic formula, the last method. That is more difficult because it has an additional step. It's the same with everything else, but it has an additional step. And let's say 63. 63 is 5x squared plus 15x minus 1 equals 0. Here is your note. We cannot complete the square if the leading coefficient is not 1. Note, make the leading coefficient 1. Okay. Always. If it's not 1, you can't. So can I make it 1? Yes, of course. In an equation, I can make the leading coefficient to be 1. How? Yep. So I have x squared plus 3x minus 1/5 equals 0 over 5, which is 0. 5x squared over 5 is x squared. 15x over 5 is 3x. And negative 1 over 5 is negative 1 over 5. And 0 over 5 is 0. Now, from this point on, everything is the same. Middle coefficient. 3 divided by 2. And 3/2 squared. Let's move 1/5 at the same time with adding 9/4. So x squared plus 3x plus 9 over 4 equals 1 over 5 plus 9 over 4. Good. Now the left-hand side I know. I made it to be that. What is it? Good. LCD on the other side. The top needs for the first one. The top needs for the second one. So then 4 plus 45. 50 divided by 20, right? So x plus 3/2 squared, 50. No, it's 49. I'm sorry. That's okay, no problem. Good. Okay, after all this work, I complete the square and I cannot finish it up. What do I do then? Right. How many solutions will I get, just in case? Yes. So x plus 3/2, and the right-hand side is? Something I can't forget? The square root of 49? The square root of 20 is 4 and 5. 2. Good, but I need to rationalize. That's why we studied it. I rationalize the square root of 5 by multiplying and dividing by the square root of, indeed. So, and I have to move 3/2 now. X equals negative 3/2 plus or minus 7 the square root of 5 over, and the denominator is? Excellent. So that was our third method. Last method, quadratic formula. Okay. So this is in 11.2. So that's the last method from that list of 4. Factoring works sometimes, not always. Taking square roots, I can always take square roots because I can always complete the square no matter what. So these two always work. This will always work. Okay? When do I use this? Unless I'm forced to. When do I use this? Basically, when it's in that form. When do I use this? When I cannot factor. If it takes me more than a minute to factor, then I use the quadratic formula, and I have to have all these coefficients. If any of them is missing, not this one, if B or C are 0, I will not use the quadratic formula. It's too much work. It's much easier not to use the quadratic formula and use other methods. Okay, here's the quadratic formula. The requirements for the quadratic formula is that there is 0 on one side. You cannot use the quadratic formula if you don't have 0 on one side. So ax squared plus bx plus c is 0. So once I set it up like this, unless it's already set up like this, then I don't have to do anything else. Then I will have to identify a, b, and c. And after I clearly, with the sign in front. So b is taken with the sign, a is taken with the sign, c is taken with the sign. If the leading coefficient is -1, I will always multiply first by -1. I refuse to solve a quadratic equation using the quadratic formula with a negative leading coefficient. Don't do it. You can always get rid of it. So once I identify a, b, and c, then the quadratic formula will give me the answers right away. Here it is. Negative b plus or minus the square root of b squared minus 4ac over 2a. Find the tune to it. If you apply it 10 times, you should remember it. Negative b plus or minus the square root of b squared minus 4ac over 2a. Now, just this piece, and I'll come back to it, just this piece without the square root, it's called discriminant. Discriminant. So the discriminant is b squared minus 4ac. I will talk about this, if not today. I know I have 10 minutes left. If not today, I will talk about it extensively. We need this, you'll see. But now let's apply the quadratic formula in a couple of equations. Let's start with this one, 14. On page 669. 1/6 x squared plus x plus 1/3 equals 0. No one is afraid of this because what? Right. How?
Multiplying by 6.
Indeed. So the new equation,
X squared.
do I still need the 10th, or can I remove the 10th now? Oh. I was on the cover.
X squared
Yes?
plus 6x plus 2 equals
Good. Is this equation ready for the quadratic formula?
Yes.
Does it have a negative leading coefficient? Do I need to multiply both sides by -1? No. Can anyone identify a, b, and c for us? A, B, C. Excellent. All we have to do is carefully replace in the quadratic formula A by 1, B by 6, and C by 2, and perform the calculations which become just arithmetic calculations. So x equals, can anyone dictate? Negative b. Very good. Plus or minus the square root of,
6 squared,
which is
36.
minus 4. Let's write it like this. 4 times a, which is 1, times c, which is 2. Everything divided by 2a. How much is 2a? 2. Now be very careful. We cannot take square roots from terms. We cannot separate. We have to be very careful how we perform the calculations under the square root. Careful. X equals negative 6 plus or minus. 4 times 2 is 8. Times 1 is 8. 36 minus 8 is very good. Divided by 2. Do not attempt to simplify 2 with 6. You cannot do that. But you have to simplify the square root of 28, because we studied an entire chapter for that. So this x is negative 6 plus or minus. So this will be 2, the square root of 7. Now you can separate. Negative 6 over 2 plus or minus 2, the square root of 7 over 2. And now you can simplify. Negative 6 over 2 is negative 3 plus or minus. I can simplify a factor of 2 with a factor of 2. Please write 1 so you don't make a mistake and think it's 0. The square root of 7, and it's done. The quadratic formula is very elegant. It works only for quadratics. If you have a cubic, for example, x cubed plus blah, 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 you cannot use this. If you have x to the 4th plus blah, 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 you cannot use this. Specifically for quadratic equations only. Okay, we have time for one more. Do I choose or you want to choose? From 669. Anything you want from 1 through 22.
Would you say 1 through 22?
Yeah.
Do I'm trying to remember which ones we did already. They don't look the same.
Yep, let's do 10. They all are the same. This is n. Okay? So 11n squared minus 9n equals 1. Okay. Don't attempt to factor. It's not factorable. You cannot take square roots. No, I will not complete the square. Quadratic formula. Good. So I have to do what first? And that is mandatory. Exactly. If I don't have 0, I cannot correctly identify A, B, and C. This is crucial. So 11n squared minus 9n and minus 1. Now I can correctly identify A, B, and C. A, B, very good, correct. And C, right. So now I'm ready to write n equals negative b plus or minus the square root. B squared, if you write minus something in there, I can't give any credit. It's b squared, which means the first portion under the square root must be a positive number because we are squaring that number. So whatever it is, squared will be positive. I'm ready. Excellent. Minus. it is safe to write this. Minus 4 times A times C. And realize that this will be what type of number? I have, exactly, because I have two negatives. Over 2 times A. There is no negative. Right. Because remember, always keep the leading coefficient positive, because otherwise you're going to run into trouble if you have a negative number in the denominator. So then we have 9 plus or minus. So 4 times 11 is 44, right? 81 plus 44. I got 125. So the square root of 125 divided by 22. I know that 125 is 5 times 25. So then n equals 9 plus or minus 5. Let's go to 5. There is no need to separate this. This is it. There's no need to separate. I cannot simplify. It's done.